Nowadays, many of us are heavily reliant on electricity. We use it to power our homes, charge our devices, and light up our lives. But have you ever stopped to think about whether or not you really need all that electricity? This isn't to say that you don't need a substantial amount of energy in general. I'm talking about electrical energy needs specifically. The reality is, you probably don't need nearly as much electricity as you currently use. By taking a closer look at your energy needs and finding alternative sources of power, you can potentially improve energy efficiency as well as save significant money on your energy bills. In this video, we'll explore some of the ways you can reduce your electricity consumption and live a more sustainable lifestyle. If you like this video, please consider subscribing so you're notified of new, helpful content. Despite the ubiquity of electricity in our everyday lives, it's crucial to understand that its production is less efficient than you might think. The way electricity is generated commonly involves a multi-step process that inherently wastes energy at each stage. Consider the typical method. First, an energy source like oil, coal, or biomass is burned, converting its chemical energy into heat. This heat is then used to boil water in a confined tank, such as a boiler, generating mechanical energy in the form of pressurized steam. This steam turns a turbine, which contains a magnet surrounded by coils of wire, usually copper. The magnet and coils will have one of them stay stationary while the other moves, resulting in the generation of alternating current, AC, electricity. The various energy conversions involved in this process each result in some level of energy loss. And the more conversions that occur, the greater the potential for energy wastage. Therefore, the traditional method of electricity production involves a considerable amount of inefficiency. Some energy loss occurs during the distribution of electricity to homes and facilities. There often are long distances between where power is generated and where it ultimately will be used. This creates a significant opportunity to have significant to substantial energy loss in electrical energy from having to be transmitted a long way. In order to aid in minimizing any loss of energy, the electrical energy generated at a power plant is stepped up. This means that the voltage is increased and the current decreased. The overall power is kept about the same as what was generated. The benefit to doing this is that the lower the current, the less electrical energy is lost as heat due to conductor resistance. In doing this, the electricity can be distributed over long distances and retain most of its initially generated energy content. That said, barring superconductors, the best conductors will slightly reduce the amount of overall energy maintained as electrical due to resistance heating. Many residential, commercial, and industrial end users cannot make use of such high-voltage electricity. So, it is stepped down, increasing the current and decreasing the voltage, such that the end users can use the electrical energy safely. Given these numerous opportunities for energy wastage or other electrical energy distribution issues, it becomes imperative to devise strategies to extract more value from our energy sources. One approach would be to reduce the need for energy conversion and distribution in the first place, thereby minimizing the potential for energy loss. Just as it is crucial to acknowledge the inefficiencies and wastage present in energy processes, we must also address the inherent risks associated with energy use in general. Essentially, all forms of energy contain potential dangers. For instance, consider the combustion process that powers your automobile. Fuel is exploded within the engine, with pistons and other components transforming this explosive mechanical energy into rotation that propels your vehicle. While the engine is designed to withstand the forces generated by this process, the potential for defects or damage remains. A severe malfunction could turn this useful energy source into a significant hazard. Similarly, the heat required to cook our food can, under different circumstances, cause burns to your skin. Even the electricity that powers our everyday appliances can be lethal if mishandled. The degree of risk often lies in the dosage. A small static spark may cause minor discomfort, but a major electrical fault can be fatal. Therefore, it's crucial to remember that while energy is a vital part of our lives, it should be treated with the respect it deserves due to its potentially hazardous nature. Electrical energy is intrinsic to the functioning of many everyday devices we take for granted, such as electronics and lighting systems. Televisions, computers, cell phones, thermostats, and other electronic controllers, for example, rely primarily on electrical energy. Similarly, illuminating our homes, streets, and workplaces would be much more difficult, and perhaps more dangerous, without electricity. Arguably, most other applications do not necessitate the use of electricity from a conceptual standpoint beyond some type of controller. However, given how entrenched electricity has become in many societies, numerous devices are engineered specifically to convert electrical energy into the form of energy they require. Appliances like electric refrigerators, air conditioners, stoves, or water heaters take in electrical energy and transform it into thermal or mechanical energy. Electric cars convert electrical energy into kinetic energy to move. The pervasiveness of electricity in our lives does not always imply its necessity. Rather, it reflects how we have adapted our technology to utilize this generally readily available form of energy. Heat energy is crucial for many of our daily tasks. It is indispensable during colder months when we need to keep our homes warm. It's also integral for cooking and heating water for chores such as bathing and washing dishes or clothes. While traditional methods involve electricity, there are more energy-efficient alternatives. For instance, a wood-fired or other fuel stove can be used for home heating, providing an eco-friendly and cost-effective solution. Similarly, various fuels can be utilized for heating water for washing and bathing. These alternative methods not only can reduce electricity consumption but also present a more energy-efficient method of performing tasks. Mechanical energy is fundamental for the operation of several household appliances that require some form of motion. Consider refrigerators, clothes washers and dryers, HVAC heat pumps, and dishwashers. All these devices require mechanical energy to fulfill their functions. If you're noticing an overlap with some appliances previously covered under electrical energy, that's because many devices require more than one type of energy to function effectively. In many of these appliances, electricity is used to power a motor, which operates a bit like a reversed electrical generator or turbine. This is possible because electricity can generate a magnetic field. Motors harness the repulsive force that occurs when two magnets align with their like poles facing each other. You can try this with your own magnets and feel the effect. Of course, the process of a motor is more complex than that, but the essential idea is that motors use both electricity and magnetic fields to create rotation and, consequently, mechanical energy. While alternative methods of powering such devices, such as using a boiler, are possible, they are typically less feasible, especially for consumer versions. Thus, despite the primary requirement for mechanical energy, these devices are usually designed to utilize electrical energy because of electrical energy's wide accessibility and convenience. Lighting definitely is a critical component of our everyday lives. It's virtually impossible to carry out day-to-day tasks without adequate light. The sun, our primeval light source, generously showers us with its radiance, but unfortunately, not all homes are designed to exploit this bountiful source. As the sun descends, nightfall shrouds our homes in darkness, necessitating alternative light sources. In bygone eras, we relied on fire for illumination, whether via a candle's delicate flicker, a lantern's soft glow, or a fireplace's robust blaze. Today, advancements in technology present us with an assortment of lighting options, primarily LEDs and incandescent bulbs, powered by electricity. Although using fire as a light source can warm our homes in colder climates, it poses several drawbacks. It consumes precious oxygen and increases the risk of accidental fires, risks that are relatively low with electric lighting. Personally, I vouch for the use of electric or natural sunlight for illumination. It's been my experience that for similar energy levels, electric lights can do a better job at illuminating an area than can fire-based lights. The warm, inviting glow of a fireplace or candle is indeed charming, but when it comes to practical, efficient lighting, electricity is my go-to option. To optimize energy use, consider utilizing appliances and equipment that run on fuel sources such as wood, oil, or gas. The less energy conversion required, the greater the potential for harnessing more energy. However, if this is not feasible, there are alternative solutions. For instance, you can opt for energy-saving LED lights. Install WaterSense low-flow shower heads that can maintain comfort while reducing water usage and, in turn, the energy required to heat the water. Take advantage of the sun's abundant energy to dry your clothes or even heat your water. Switch to tankless water heaters that heat water on demand, eliminating the ongoing energy costs associated with traditional water heater designs. If you own a home in a warmer climate, consider painting your house with lighter colors to reflect sunlight and reduce heat absorption. Some homeowners even invest in infrared coatings to further deflect light that would otherwise convert to heat. While these are just a few examples, the options for improving energy efficiency are numerous and largely depend on your individual circumstances. By exploring these options, you may find surprising ways to conserve energy and reduce your utility costs. It is essential to remember that energy conservation is more of a long-term investment. While the methods mentioned above may seem appealing, it's crucial not to rush into things and make it challenging to balance your current lifestyle. Prioritize taking a careful look at your budget, identify where changes can be made, and decide on the energy-saving measures that fit within your capabilities. Additionally, some modifications may not be feasible if you're renting your home, as your landlord might not permit alterations such as painting the house. However, there is no shame in starting small. Even the smallest changes can contribute significantly to saving energy and cultivating good habits. These baby steps can serve you well later, especially when you have more freedom to make impactful energy modifications. So, assess your situation today and begin your journey towards energy efficiency. I hope you found this post helpful and informational. If you liked the video, consider dropping a like, commenting, or subscribing.